thank you everyone for joining, and I'm happy to be here to talk to you today a bit about JMP. And so just to start, I want to give you a little bit of an overview of what I want to cover today. And so this is data summary and analysis in JMP. And we're hoping that you've seen some of our earlier webinars and have it, played around with JMP a little bit. If you're very new to JMP and this is the first time you've seen it, don't worry, I'll take you through some of the basics. But for those of you who have seen JMP before, I hope that even in the basic review, you still get some new information from me. So one thing that always amazes me about JMP, I've been using it for over 8 years, and anytime I see somebody show JMP or talk about JMP, I always pick up something new. So it's a really deep product, and it's always fun to learn more. All right, so what I'm going to do today is talk a little bit about just the JMP family of products, the basic anatomy of JMP, especially for those of you who have never seen it before. We'll talk a bit about summarizing and graphing data in JMP, some basic analyses. We'll get into a little bit of advanced methods, and I'll make sure to point you in the direction of resources for those of you who are just learning or if you're teaching JMP. We try to put a lot of resources on our website, just to make it easier to teach with. So I want to definitely point you in that direction. All right, so with that start, let me actually minimize my web browser. And what I want to do is start using JMP right away. And so for this presentation, I'm using a JMP journal. And journaling in JMP is a great way to keep track of your analyses, but it's also a great way for making an outline for a presentation. So for those of you who are teaching, I really encourage you to look into journaling to make your course outlines. It's a great way to just bring up analyses quickly and link to all your data sets. So to start, I just want to give you a quick just rundown of what JMP is. So if you've never seen JMP, JMP is desktop statistical analysis software, and it's made by SAS. And the point of JMP is to be a very visual and interactive way to explore your data. JMP has deep analyses, but it's also a very visual piece of software. Now, JMP is actually a family of products. Now, what I'm using is JMP Pro 11, but JMP also comes in some other varieties. JMP Clinical, especially working with clinical data, a really great way to investigate those types of data because it has very specific analyses. And also JMP Genomics. So if you're working with specialized data for genomics, certainly there's some very specific analyses. So I won't talk too much about those, but for those of you who are at academic institutions, there is something called the JMP Academic Suite, which is it's a special version of JMP that comes with JMP and JMP Pro, which runs on Mac and Windows. And as a license for an academic institution, it also comes with an e-learning course. So if you have any questions about this, certainly feel free to follow up with me later on. Now, if you're interested in getting JMP, there's a free 30-day trial on our website, so you can try it right away. If you want to or are interested in campus licenses or departmental licenses, I have a contact here of our salesperson, Pawnee Allen. So if you're interested in JMP after seeing this, or if you already are, give her an email. And if you're at an institution but not interested in a department or campus-wide, we have an academic licensing site on thehub.com/JMP where you can get annual single-user licenses. So when I was teaching, my department didn't have a license, so this is where I would send students to get their copies of JMP. So there are 6-month and 12-month licenses at really reduced rates. So for students and faculty, definitely less expensive than it is for commercial customers. All right, so with that basic introduction, let's take a little bit of an overview of the anatomy of JMP, the way it works with data, and some things we have to keep in mind when setting up our data sets. And so to start, I'm just going to click this link. I made a link to some sample data. These are restaurant tips. Now, I'm going to normally be clicking the links in my journal, but just so you can follow along or find these data sets later, I want to point you in the direction of them. They're all under the Help menu under Sample Data. Now, JMP ships with over 400 sample data sets, and when you launch the sample data list here, it'll give you them organized by types of analysis and types of field. And we also have a number of teaching resources and demonstrations, calculators and simulations all built in here. But if you want to get to a particular data set, the way I normally do this is just click Open Sample Data Directory. And so this will give you the list of all the sample data. And the one I'm using, which you saw just a second ago, was restaurant tips. So if you want to find that, just scroll down and open it from here. But since I already have it open, let me just go back to my restaurant tips file. Now, if you've never seen JMP before, this may look pretty familiar from your work with probably spreadsheets. So JMP is set up just like a spreadsheet software to have rows and columns in which to keep your data. Now, a custom in JMP and in most statistical software is for each row to represent a unit of analysis. So in this case, one unit here is one person's tips, percentages, whether they were using a credit card, the guest, the number of people at the table, the day of the week, right? These are all values or attributes of this unit of observation. Now, in other software, like Excel or other spreadsheet software you may use, we sometimes get a little fancy with how we set up our data sets. We have spaces at the top with several rows just to make things look prettier. We sometimes put in extra columns or have other values in certain columns, like equals average or things like that. So what JMP does, and something you have to keep in mind, is that columns really have to be one type of data. And the reason to do this is that JMP will be making decisions for you, really to help you out for what types of analyses to show, based on the data in a column. And so let's just look at this data set for a second, right? I have for each of these units, the bill amount, so how much people were buying at this restaurant, the tip amount, whether they used a credit card, right? So already we can see we have some different data types here. Tip amount and bill amount are dollars, right? Whether they used a credit card or not is really a dichotomous choice. It's binary, and it's categorical. It's really a yes or a no. And if you look on the left-hand side here, you'll see that JMP has recognized that this is a different type of data because it has this little red histogram. And this is showing for us that JMP is calling this column nominal, right? It's a nominal categorization. It points out categories. Same thing for day of week over here, right? Day of week isn't really a numeric measure in the same way that tip amount and bill amount would be. It's really a category. And so JMP keeps track of this for you, but it's really important when you bring your own data in to make sure that you set up all of these modeling types correctly. And the way to do this is if I right-click on this little icon, you'll see I have the option to set different modeling. And so in this case, it's defaulted to nominal. And in fact, continuous here is grayed out because JMP knows with text data, you really can't have a real underlying scale. Number of guests, on the other hand, right, this is marked as continuous. If I right-click, you can see we have the option to select other modeling types. Now, this is important to note because sometimes when you're working with even continuous data, you may in fact want to be treating those categories or those values as nominal. And so as we go forward today, I may change a couple modeling types just to get different types of output. All right, so that's the modeling type. Now in JMP, unlike some other statistical software, there's really only one data view. So if you're familiar with SPSS or some other types of statistical software, there's sometimes a variable view which has all the variable properties. Now in JMP, to get to column properties, you simply right-click a column and select column info. And this will bring up all the different types of options for the column. So you'll see for tip amount, I'm listing this data type as numeric. I'll show you the other options here. If we have data that's simply character, that's how it will be stored. And row state is a special type of variable that lets you hold information about exclusions or other information that you'd want to capture about your rows. But for now, I'm just going to leave that as numeric. I've set the format here as currency. And under column properties, there's a number of different options that work for when you have to do specific things with a column. Things like value ordering, if you want to change the order of observations in a column, or things like value coloring, or even labels for observations. So column info contains all the options for setting up particular column up. Now, if we look across our columns here, right, we have 7 of them, right? Each of them is containing different types of data. And the important thing, again, to consider is that each column contains only that type of data, right? If I scroll down, right, we don't have things like equals average, or we don't calculate means in a table. The table is really set up just to hold your data. And all analyses will live under the different options in our menus. And so I just want to give you a brief overview of what these menus are. So today we're going to spend most of our time in the Analyze menu and the Graph menu. These are both the seat of really all the analyses you would want JMP to run and all the graphics you would want JMP to produce. We'll also spend a little bit of time working in the Tables menu. So tables is really when your principal interest is creating some type of summary, right? Statistical summary of the data, or table operations that lets you reconstruct or manipulate how your data is formed. So things like splitting or stacking columns, things like sorting, transposition, those are all table operations to, reform or reshape your data. Now, something important about JMP, and I have a whole section for it here, is that JMP has a progressive interface. And what I mean by this is when you generate output in JMP, you'll actually be given new options once you've generated that output. And those options will depend on the types of variables you have. And so before we get in too deep with analyses, I'm just going to launch an output. I'm going to use the distribution platform. And I want to show you what I mean about it being progressive. So I'm going to take a couple of these columns. I'll take tip amount and whether a person used a credit card or not. And I'm going to put them into the Y columns and click OK. Now I'll talk more about the distribution platform in a minute, but I want you to notice two things. First, that JMP has contextualized the output on the basis of the modeling types. So tip amount, if you recall, is continuous. And so these values actually are of an underlying scale. And so it makes sense to calculate things like means and standard deviations and quantiles, right? Those make sense for continuous data. For the categorical data of credit card, the yes or the no, right, we're given a frequency table. And even these different distributions are actually somewhat different. On the right-hand side, we have a frequency distribution, and on the left, we have a proper histogram. Now, these red triangles, and you'll see them all over JMP, these are really where you find the new options that have been generated on the basis of your existing output. So if I click the red triangle next to credit card, notice that these options let me dig down more. So once I've gotten an idea of the overall distribution of yes and no, maybe I would think I want to test those proportions against maybe a null of 0.5, that people in general don't have a preference to use or not use a credit card. Right? Those options will live under the red triangle for credit card, and here's the one for test probabilities. Additional things like confidence intervals, getting a mosaic plot, or even changing things about the histogram, right? Those are all contained under that red triangle. So that's what I mean by it being progressive. Now under tip amount, so a red triangle for a continuous column, notice that those options are different. Right? JMP is contextualizing or giving you specific options based on what's appropriate for your data. So as I dig deeper, maybe I would want to test the mean of tip amount, supposing I have some null hypothesis about what the tip amounts should actually be on average. So JMP is progressive in the sense that as I produce output, I can keep digging down and find out more based on what I've already set up. And so as I'll talk about more in a second, JMP is really set up, at least when you choose analyses, around the structure of your data. So instead of choosing an analysis from the start, saying like one sample t-test from a menu, JMP instead asks you what type of data you have and then presents you those options when they make sense. All right, so that's the basic anatomy of JMP. So the red triangles would be very important. If you're ever looking for an option in JMP, I always say find a red triangle or right-click a table. So I'll show you those a little bit more. So let's actually jump right into some summarizing and graphing of data. And so for this, I'm actually going to hide my restaurant's tip file. We're going to come back to that in a minute. And what I want to do is bring up a bigger data set, one that would actually be somewhat challenging for us to summarize. And so what I'm going to bring up is something called US demographics. And so this is for all 50 states. We have 16 columns. And so we have a column representing the state. And so again, you'll notice that our unit of analysis here is at the state level. Each state occupies a single row. We have for each state items like household income, IQ, the region. We have information about population, 8th grade math, high school graduates, and gross product. Right? So we have a lot of information about state level characteristics. Now, sometimes our main interest is simply to summarize these data. We would like to know the means and standard deviations of these different columns. Now, there's a lot of ways to do this in JMP. And one of the things about JMP you'll find is that there's many different ways to get to the same answer. But there are often particular platforms that make it most convenient or give you the best information or organized it in a way that's most useful. So if we're simply interested in getting really basic summary statistics for these continuous columns, the first place I want to point you to is the columns viewer. And so this is under the columns menu. So I'm going to scroll down here. So the columns viewer, if I can find it. Here we go, columns viewer. So the columns viewer is useful in a lot of different ways. If you're searching for particular columns, I have one data set which has over 1,200 columns, and I use the columns viewer all the time because this little red triangle lets me sort them by name or even search for particular columns with names that start or end with certain things. So really useful for just a data management side. But the columns viewer also has this great property where if I select a number of these columns, I can simply click the Show Summary option. And so what this will produce for me is this nice little summary table here, showing for each of the columns the number of observations, if I have any missing observations. And so at a first glance, this is great for checking data integrity, making sure I'm not missing things. We have min and max, also useful for checking if all of our values are within ranges we would expect, and our standard mean and standard deviation. If I right click on this, notice that I can turn on and off some of these. So under columns here, I can deselect if I don't want to see the min or if I don't want to see the max. And so this gives me at least a quick way to create a table that lists the basic attributes. Now again, because JMP is progressive, we'll have these red triangles that allow us to do more things. So if I click the red triangle here, I can click Data Table View, and this will actually create a proper data table for me if I wish to go in and edit some of these, change the character types, or other things like that. So with JMP, you can always dig down a little deeper once you create output. So the columns viewer is nice when you're doing basic overviews of your data, if you just want means and standard deviations, right? But it's not the easiest way to get a lot more information. Notice it is fairly limited in what else we can obtain. And so the next place I would want to show you is this Analyze Tabulate platform. Now, if you're using JMP 10 or an earlier version of JMP, the Tabulate platform used to live under the Tables menu. It's been since moved in JMP 11 to the Analyze menu, because with Tabulate, you can actually do some proper analysis. So I want to show you what that looks like. So I'm going to go to the Analyze menu and select Tabulate. Now, Tabulate is really neat. I remember when I first started using JMP, this was one of my favorite platforms because it made something that was normally so difficult just so easy. And so what Tabulate is an interactive, it's a drag and drop table creation platform. And what it does is have these drop zones for rows and columns. And what JMP will do is show you the resulting cells on the basis of whatever you are giving it. So I want to show you just how this works. Let's imagine that we wanted to make or tabulate an aggregation of our data using region, right? So if I drag region here, I'm going to drop it in the drop zone for rows. Notice that when I hover it, that drop zone will get highlighted. Let me drop that there. And notice what JMP does at the very start is show me the different levels of that variable and shows me the number of observations for those different regions. And so, of course, this adds up to all the states in the country, and that's the number of states in each region. All right, so not a very interesting table, but of course, we've already gotten a little bit more summarization from our data, right? We've summarized something. Now, let's imagine our principal interest here is alcohol consumption. So if that's the variable we want to make a summary of, I can click and drag that variable on top of n. And notice when I hover over n, it's going to be highlighted. So let me drop it there. Now what JMP interprets that as, my action, is that I want to create some summary statistic on the basis of that variable. Now the default is the sum of all the observations in each region for the alcohol consumption variable. Now typically when we're making summary tables, at least for me, what I'm interested in generally is the mean. And so on the left-hand side here, you can see we have a lot of different summary statistics. I'm going to click and drag the mean and drop it right on top of sum. And what JMP interprets that to mean is that I would rather JMP calculate the mean of alcohol consumption within each of these regions. And you can see that's what JMP has created for us. And so Tabulate is a pretty useful way of creating these summary tables. And of course, we can make more complicated tables if we have other variables and we wish to nest those variables inside. So if I have another categorical variable and I wanted to break apart instead of by region, but by something else, I can simply drag it across and drop it on top. Now, Tabulate is very useful for creating these tables, but sometimes we want to create a table like this and then save it as a proper data table for us to manipulate or work with further. Now, like most things in JMP, that's again an option under the red triangle. So if I click the red triangle here, notice I can click Make into Data Table. And just like I did for those column viewer data tables, I can make this into a data table I can work with further. And so sometimes you'll simply just aggregate data in Tabulate to make a data set that's possible to analyze with other procedures. And so Tabulate is a very useful platform for creating these tables. And notice you have a lot of options for the summary statistics you can use. Now, we're not limited with just showing one summary statistic either. When we did the columns viewer, we were able to get a mean and standard deviation. To do that here, I can grab another summary statistic, and instead of dropping it right on top of the mean, notice what happens when I go to the right-hand side. Notice that the selection, or the highlighted drop zone, is actually to the right of mean. If I drop it there, JMP will add the mean and standard deviation both as summary statistics for alcohol consumption. Using that same logic, I can take another variable, let's take college degrees, and instead of dropping it on top of alcohol consumption, let's go right to the right-hand side. So again, this is telling JMP, I want another summary table that's built out of this variable using those summary statistics of mean and standard deviation. And so notice in this way, we can build quite complicated summary tables just by simply dragging and dropping. Now, if you ever make a mistake, you can always use undo. So there's sometimes when you use Tabulate where you'll just accidentally drop something in the wrong place, like I just did there. And so undo is a really nice thing to have, just to step one step back. All right, so that's the Tabulate platform. Now, another platform for summarizing or really graphing data is the Graph Builder. And so Graph Builder is a visual equivalent of the Tabulate platform. And so this isn't going to be under the Analyze menu. So this is under the Graph menu. And the reason it's here is because, in principle, the Graph Builder is meant for visualizations, right? It's really meant to display. Now, one thing you'll see about JMP is that often platforms will give you a visual with any summary statistics you want to produce. But the Graph Builder is really meant to create those graphics directly. And so just like I did for the Tabulate platform, the Graph Builder lets me actually create graphics by simply dragging and dropping into different zones. So before I drag and drop anything, let's look at what these zones are. I have a zone for the x-axis. I have a zone for the y. I have a grouping for the x-axis. And so this is when you want to break apart some visualization on the basis of another variable, and you would want that to be broken apart in sections along the x-axis. I can do the same type of thing along the y-axis, so breaking apart an analysis along the sections of the y. Wrapping is sort of like these grouping variables. It breaks apart whatever I'm displaying in a little grid. I'll show you what that looks like. Coloring and size allows me to use the levels of a variable to color points or to size points. An overlay allows me to create multiple displays in the same window based on the levels of a variable. So let's actually try this out with a couple of these variables just to see what this is doing. So let's imagine again, our chief consideration is alcohol consumption of a state. So I'm going to drop that into the alcohol consumption, into the drop zone for the y. Now notice what JMP is doing from the start. So I have no x defined here. And so what JMP is showing me is each state. If I hover over a state, you can see it shows me it's row 49 and its alcohol consumption was 7.5. Right? It's just showing the states, and their vertical distance is actually the alcohol consumption measure. But their horizontal jitter, that's just to show you the points, right? If those points weren't jittered, they would all be on top of each other. So right now, all we've done is show the alcohol consumption variable. Now, even at this point, I have different options for how I can display these data, right? So this is a kind of scatter plot. It's not scattered based on an x. But oftentimes, we may want to look at a single variable with a box plot. And so this ribbon up here allows me to click in different visualizations to show these data. And so when I click the box plot here, notice what JMP did is create a box plot for just alcohol consumption over the entire data set. Now what's neat about Graph Builder is I can take this visualization, so alcohol consumption with just a box plot, and I can break it apart by another variable. And so if I'm using a box plot, and I want to break it apart by another variable, I should look for one that's nominal, so I can have different box plots across some level of another variable. Let's use region. So region is a good categorical variable. I'm going to drop this right into the drop zone for x. And notice what jump does is creates the box plots now for the different regions, right? Showing alcohol consumption in each region on average. Now there's some other options if I'm just showing region differences. One that I particularly like is called a contour. And so just like the box plot, it's going to be attempting to really display where the mass of data is. And so just like the box plot, we can see the maximum and minimum. We can see the fatness here really representing the central bulk of data, right? So the Midwest has more or less a symmetric view, right? Most of the data is in the center and some extremes. Whereas something like the South, let me ignore this here, something like the South has some extreme values in the top, but clumps of data down below, right? So this contour is great. It's a good way of showing data really easily. Now with the ribbon, I can click between different visualizations, or I can click and drag a section on. So if I want to have this contour plus, I would like to have the points. And so this is often useful, especially when you're trying to display something like this, where in this region, right, the Midwest, right, there's one point here that's quite extreme, and the rest of them bulk up around the center. All right, so that's when I'm using a categorical variable against this continuous variable. Let me click Start Over and show you some options when I'm looking at two continuous variables. Let's again assume that alcohol consumption is our principal interest. And let's see how that changes on the basis of the proportion of smokers in a state. And so I'm going to drag smokers down here to the x. Now what JMP's going to do whenever you drag variables in is just choose a visualization by default. So with two continuous variables, that default is called a smoother. Now smoother is kind of like a lowest regression, or it's a spline. It's a moving average that allows you to change really stiffness. Now to change that stiffness, under lambda here on the left-hand side, we have a little control slider. And so I can drag that slider to the left to make this moving average recalculate more quickly, or drag to the right to make the line stiffer. When I drag all the way to the right, I'm given what is essentially the linear regression of alcohol consumption onto smokers. Now, if we're interested in that linear regression, there's actually a toggle here, and I'll click it, which gives me the actual linear regression line and showing me the confidence on the fit, so a working hoteling confidence band. And so with this, I'm able to look at the linear relation between alcohol consumption and smokers. And even though this is a graphical platform, you'll notice on the left here, let me click and drag down, I can turn on the equation, the root mean squared error, or even the coefficient of determination, the R-square value here. So I can still get some summary statistics. Now what's neat about Graph Builder is suppose you see this relationship, alcohol consumption and smokers, but you're interested in how that varies as a function of region. And so we have some other sections here that we can use region in, the group for X, the wrapping, or the group for Y. We could also use region as an overlay. So what I'm going to do now is I'm going to grab this region variable, and I'm going to slowly drag it around to different drop zones. So here we are in the drop zone for X. And so notice what it did is break apart this analysis, right, the regression, into 4 sections. If I drop it in the group for Y, notice it does that same thing, but breaks it apart in the Y dimension. Now wrap, you'll find to be actually quite useful sometimes, which will break apart this analysis into this little grid. Now something that's really neat about wrap, and I'm just going to drop the variable there for a second, is oftentimes with 4 levels, these wraps look great. But if you have a wrapping variable that has hundreds of levels, you may not want to see all 100 at the same time. So if you right-click, once you've set the wrap variable, you can specify the number of levels to show at any given time. Let me click 1 so you can see how this works. When I click 1, I'm now shown the Midwest, but I can click this right arrow and I can toggle through the different regions. And so this is great for demonstrating, or especially when you're showing data to people, you can have your wrap variable be particular conditions across which you would want to show some relationship, and then you can click through them to show the differences. And so again, that's by right-clicking and setting the levels in view to something other than all. So I'll go back to 4 at a time though. Now I'm going to drag this region variable out one last time, and I want to show you what it looks like in overlay. It's going to look a little messy here, and so I wouldn't recommend this as the best visualization. But we can clean this up a little bit. So I'm going to turn off the confidence of fit, equations, roots mean squared error, and r squared. And notice that this does give us a good idea of whether the regions really have a similar regression of consumption onto smokers, or alcohol consumption onto smokers. And we can see really actually that overall relationship, let me drag it off of region, so that overall negative relationship between alcohol consumption and smokers, right? If we look at across regions, it looks pretty variable. Some states are increasing quite a bit in the relation, some are decreasing. Actually, most are decreasing here, but we have one aberrant state. All right, so Graph Builder is an amazing platform for creating these visuals, but it's also a great platform for exploration. Because it's so simple to drag and drop variables in, you can visualize relationships quickly just to see what maybe you want to investigate more of. Once you're done with the graphic, you can click Done to close the control panel, and now these graphics can be copy and pasted out to other software or into Word documents and PowerPoints. All right, so that's the Graph Builder. Now, one final thing I want to note is when you're summarizing and graphing data, there are times when you only want to consider a subset of your data. And so there's a great way to do this, which is the data filter. And so this is available under the Rows menu at the very bottom. And what data filter is, popped up on my other screen, there we go. What data filter is a way of making a selection of your data based on variables in your data set. And so to do this, at the very start when we launch data filter, it's asking us for some column on which to make an exclusion or selection criterion. So I'm going to select region here, and I'll click Add. And so what this allows me to do is let me click just the South here. If I click South, notice that JMP selects all those states in the data set. Now, this little toggle right here says Select. And so this top bar is actually what I want JMP to do when I dial in a particular section or state. And so these other options, Show and Include, add additional things to the row states. So by clicking Show and Include, I'm telling JMP that I want to only select, show, and include in analyses those states which I have selected here. And so what this means is when I produce an output, let me go back to Graph Builder. Let me add back in what I had before. So this was alcohol consumption as the Y and smokers as the X. What JMP is going to do is as I toggle through these, it'll change which region is shown and included. Now include and show do similar but distinct things. Include is whether to include the rows in any kind of analysis. And so if I uncheck include, in this case, JMP will include every data point in whatever demonstration or analysis I'm using, or in whatever visualization or analysis I'm using. Show, on the other hand, let me go back and bring back my data filter. Show, on the other hand, is whether those points are shown in output. And so if I click different observations here and click and unclick Show, notice that they get shown in the output when Show is unchecked, but they get hidden if I tell the data filter to only show the ones I have selected. So Show and Include can be used in different ways. Normally, I'll click both or have neither clicked, but it's good to know that JMP can do both types of exclusions. All right, so that was Graph Builder and Data Filter. Great ways of understanding your data, and Tabulating Columns Viewer, great ways of summarizing your data. Now, with that, I want to move into some basic analyses. And so we're actually going to be able to do several of the things we've already done, but get additional output and some hypothesis tests if we want on the basis of the data we have. So I'm actually going to close demographics here. And just because I like this data set, I'm going to bring back my restaurant tips file. So I want to talk about 3 platforms in JMP. The distribution platform, which is meant for really univariate or one variable at a time questions. The fit y by x platform, which is meant for 2 variable questions, so bivariate. and fit model, which is actually usable for any type of modeling, but most of the time when you have more than two variables you wish to consider. And so let's start with the distribution platform. And as I said before, JMP is really going to contextualize your output. It's going to give you output that depends on the modeling types of your variables. And so when I go to the distribution platform, what I like to do, typically when I get a new data set, I always like to visualize all of the univariate distributions. So no matter how many variables I have, I want to see what type of data I actually have. And the best way to do this is creating a histogram for all of these variables, or if they're categorical, a frequency distribution. So I'm going to select all the variables, click them into Y, and then click OK. And what JMP does is produces that histogram table, so with all the different variables, like we saw before. Now I'll make one point here. I didn't mention it before, but most of you, if you haven't used JMP, are probably used to seeing histograms in a horizontal layout. And this is actually how most books present them and historically how people have seen them. Now what JMP does is turns them on their side and shows them vertically. Now on one hand, this is actually a very natural thing to have for a histogram because up means higher in the scale. Now it's kind of interesting when they're on their side. I've gotten very used to more to the right, meaning higher up in value. But as I've used JMP more and more, I've gotten used to this layout and actually quite prefer it. Now, if you really don't like your histograms to be vertical, there's always options to customize output in JMP. And that's going to live under this very top red triangle, and it's called stack. And so if you want your histograms on their side, just click stack, and JMP will reorganize the output so that you can be scrolling vertically here and see your histograms like maybe you're more used to. I'm going to go back to putting them on their side though, because this lets us see not only more distributions at once, but it's also the way that JMP will do it by default. Now with the distribution platform, notice that we can, like I showed you before, drill down into any one of these different distributions. So let's take number of guests, for instance. So let's say for this restaurant, they know that the average number of guests should actually be 2 per whatever period of time they're measuring. And in this case, our mean was 2.09. And so being that this is a sample, of course, we expect sampling error. So we shouldn't expect our statistic of the mean to be equal to whatever population parameter we expect. But maybe we want to test this. Did we get a biased sample? Did we happen to sample at a time when there were more guests coming to the restaurant? Or sorry, more guests per table in the restaurant. So let's actually test this. Again, in this progressive interface, these options will live under the red triangle. So we'll scroll down to test mean. So testing mean is where we would do our one sample t-tests or z-tests. And so to test this hypothesized mean, assuming we knew that over a long period of time, the population average should be 2 guests per table, I'm going to put in 2. Now, let's assume we don't know a true standard deviation, since oftentimes in any kind of research we don't. But if we did, we can enter it here to get a z-test. And now I'm also going to select the Wilcoxon signed rank. So this is a non-parametric version of this test. When I click OK, notice that JMP will add that output to the bottom here. We have our test mean, including our null hypothesis mean, whatever actual estimate we had, degrees of freedom. And the way JMP is going to give us the output is our t-test here, that's the test statistic, and our p-values. So we have p-values and our test statistic for both the t-test and that Wilcoxon signed rank. So just a matter of convention, for tests that have a one-tailed or two-tailed distinction, JMP is going to call the two-tailed test the probability greater than the absolute value of, and then whatever the test statistic is. In this case, it's the t-test. And so the proportion greater than the absolute value of t, right, in this case is 0.20. So our two-sample t-test not really showing us convincing evidence that this mean, 2.09, is very different from the population mean we would expect by chance. So in other words, we don't really have license to reject the null. This is probably just sampling error. If you want one-tailed hypothesis tests, you just simply have to look for the p-value in the relevant direction. So the rule of thumb is always your directional hypothesis is in the direction of the alternative. So if we assumed for some reason we would have more individuals, our p-value would be this one, greater than the absolute value of t. All right, so that's the test mean option. Now let's look at another option here. So under credit cards, for a one sample test here, the only one sample test we would have is if we expected some certain proportion of our tables to have used a credit card or not. And so in this case, this would be a testing of probabilities. Let's assume, for instance, that over a long period of time, actually it should be 50-50. Half the tables use credit cards and half don't. So to test that probability, I just selected the test probability section, and JMP is asking me to enter my hypothesized probabilities. So let's just do a simple one here. So 0.5 and 0.5. So under the null hypothesis, we should expect to have observed an equal number of yes and no tables. When I click done, JMP will give us that chi-square test. So this is a chi-square goodness of fit, with the null hypothesis being equal proportions in each of the categories. And in this case, you can see our p-value is less than a typical standard of 0.05, indicating that in this case, we have rejected the null, right? Observing this proportion of credit card uses is actually unlikely to happen if really we're sampling from a population where everybody is equally likely to use a credit card or not. Right, that's the typical idea of our p-value. How unlikely is something to happen given that the state of the world is some predicted way? All right, so the distribution platform, so you can see, gives us really all of our one sample tests. Now there's additional things we can do with the distribution platform, things you may often come across like fitting distribution. So if we had some a priori reason to think that, let's say, tipping amount should be normally distributed, that's something we can actually check. So again, with this progressive interface, this will live under that triangle, and we can fit, let's say, a normal distribution to these data. Like it always does, JMP will put that additional output right below. And again, we're given yet another triangle if we want to do additional things with our normal distribution fit. Diagnostic plots, we can get a goodness fit test, so the Shapiro-Wilk. We can actually get a test against the null hypothesis that the population is normal. And some other things, spec fits, quantiles, additional options like that. Now, the distribution platform, as I mentioned before, is univariate. So its principal purpose is to help you understand questions that are of a univariate or one variable nature. But because of the way JMP links data across all the analyses, this data set actually, or this output, allows me to investigate, at least generally, some bivariate questions. For instance, do I think people tip more when they use a credit card versus when they don't? Well, I can address this question, or at least look at it, by clicking the yes or no column. Notice what JMP will do. So this is the dynamic linking of data in JMP. By clicking no, I can see the marginal distribution of all those tip amounts for no credit card use, and I can see the tip amounts for yes credit card use. And on the basis of purely this visual inspection, it looks to me actually that people who were using a credit card, or those people who used a credit card, tended to also tip a little bit more. And so this being dynamically linked allows me to investigate, at least generally, bivariate questions simply. And I'll show some other things here. If it's a histogram, I can click and drag to select bits of that. So I can look at the biggest tables, so selecting from number of guests from 8 down to 3, so I can actually see what their tips are like. So by having this dynamic linking, I'm able to investigate these relationships in a way that, isn't using the bivariate platform, but just a way to overall look at the relationships in my data. All right, so that's the distribution platform. So I want to step forward to another very widely used platform, which is FitY by X. Now, FitY by X, like all platforms in JMP, is contextualized. And so the way, and I have a little table here just to give you a little rule of thumb. This will actually show up also when you go into the FitY by X platform. So this is under Analyze again, FitY by X. And this little table is a helpful guide for what type of output you're requesting. And so the way to read this is, if your X variable is continuous and your dependent measure or your Y variable is nominal or ordinal, that puts you in the domain of a logistic regression. If, on the other hand, you have a continuous X variable and a continuous Y variable, that puts you in the domain of bivariate. Similarly, if you have a nominal or ordinal variable fitted against another nominal or ordinal variable, that's a contingency analysis, like chi-squares. And if you have a nominal or ordinal variable fitted against a continuous variable, right, that's a one-way analysis. So that's the domain of analysis of variance and comparing means. So let's step through a couple of these. I'm going to try a continuous y against a nominal or ordinal x. So again, this puts us in the domain of a one-way analysis. So let's actually look at some of the questions we had. So I'm going to take a couple different variables. We'll try a few of these. I'm going to pick day of week. So this is the day of week that a particular restaurant transaction happened. And I want to look at whether day of week relates to tip amounts. Do people tip more or less particular days? So notice when I click that Y, one way showed up here. So that's just JMP telling you this is the type of output we're going to get. When I click OK, what JMP will reveal for us is this dot plot. Now, one thing I always like to do, and that's why I have it listed here, display options, points jittered. Whenever I get this kind of output, I always like to go to the red triangle, go to display options. So these are options for how I want JMP to display this graph. And I like to put points jittered. And the reason I like to do this is this lets me see the clusters of points, because if they're all right on top of each other, it's actually pretty hard to see how many there are. Now, another thing to notice about this output is that the x-axis here is scaled proportionate to how many observations there are. So because the Wednesday category is much wider than the others, that's a way of JMP telling you there's more observations on Wednesday. All right, so with this output, right, we haven't gotten any statistics yet. This is really just the visualization. But again, because of the progressive interface, we can click this red triangle and request the types of outputs that would make sense. So in this case, we may be interested in performing an overall analysis of variance. Do we think, based on the sample data we've obtained, that in the population, the average tip amount differs among these days of the week? Of course, not with any specific prescriptions of which days differ, just do we have evidence that there is some difference among the days? So let me click means ANOVA and show you this output. So what we get is another section here, the one-way ANOVA. We get a summary of fit, showing us the overall R squared. We get some other information, so the root mean squared error, often useful. We get an overall analysis of variance test, so our p-value for the omnibus ANOVA. Do we think there's any evidence for differences among any of these days? And in this case, we haven't rejected that null. So the variability from day to day in tipping seems to be easily attributable to chance or noise differences from sampling error. We also get our means and one-way ANOVA table, including the confidence intervals for each of these different groups. Now, it's often the case, and so I'm going to hide actually some of these just by clicking the gray triangle. Now, it's often the case when we have groups like this. So in this case, we have 5 different groups. We may actually not want to run the overall ANOVA, but we actually really need to do every pairwise test. So comparing Monday against Tuesday, Wednesday, Thursday, Friday, Tuesday against Wednesday, Thursday, Friday, etc. So that's an option here as well. And so I'm going to actually expand this comparing means section because we've already done the means and ANOVA, but I want to show you how to get those pairwise tests. So to get the pairwise tests, if I click this red triangle, under compare means, we actually have several different pairwise options. So the very standard or very common method of students t-tests, we can actually just click each pair, students t, and JMP is going to produce for us all the comparisons between each different group. So if I scroll down, there's a lot of output here that we can talk more about, but under ordered differences, you can see each level compared against each other level, showing us the p-values and confidence limits on that difference. Now, a problem that's often a problem in research when you have a lot of groups is that these comparisons with students' t-tests aren't controlling for an overall alpha. That is, every one of those tests was done at an alpha of 0.05. And if we have a lot of different tests, our family-wise error rate is actually quite increased. So because of this, JMP includes several different ways to compare means while also controlling your overall alpha rate. And so all pairs using Tukey's HSD is one way to do this. So this is a test that actually controls the family-wise error rate to be 0.05 or whatever you specify. There's other options, so controlling with best. This is basically a comparison of the best group against the others. And if you have some specific control group, and I'll show you what this looks like, we can use Dunnett's test. So let's say Monday is our baseline, and we want comparisons for every other day against Monday. So not all pairwise tests, but simply every other group compared against Monday. If I run that test, notice we get similar looking output, but instead of getting all the comparisons, like we did up here, we'll simply get the comparisons against Monday. Like always, progressive interface gives us some different additional options, so we can request the difference matrix and other things like that. So that's fit y by x using a continuous y and a nominal or ordinal x. Let's try another one of these. So I'm going to jump right ahead here to nominal ordinal with a nominal x. So categorical by categorical. And so I actually had a question in here. This may be something if, let me go back to fit y by x, something if these were your real data, we may just want to see something very simple. Do we think that the servers that we have in our restaurant here, do we think that they're equally spread out throughout the days of the week? Because if we're doing analyses and we're looking at day of week, we may want to make sure we don't have server effects. So let's actually look at this. Let me put y as server and day of week as x. And this will bring up contingency as the type of analysis. And when I click OK, JMP will produce this really great graphic. It's called a mosaic plot. Let me actually hide the contingency table so we can focus on this. So this is showing us for every day of the week which servers were working. And so let me help you read this first. So this right-hand side, which I'm going to click and drag out, shows us the overall share for server A, B, and C. So just looking over here, we can see that server A worked a little bit less than B, but C worked very few days, right? So this is the overall share. We can also see, remember we saw that Wednesday was the most represented category. Again, the scaling of the X here represents the proportionality of that observation in that column. But we can also see within each day of the week which servers were working. So on Monday, only B was working. Tuesday was A and C. Wednesday was all three of them. So was Thursday and Friday. That's slightly different proportions of tables they had actually served. So we can actually test the hypothesis. Do we believe that servers are equally spread out across the different days of the week? And in this case, we've rejected that null, giving us statistical evidence that there's something systematic about these schedulings. Sort of makes sense. We're not just randomly assigning servers to different schedules. They probably have preferences for different days. All right, so this is a great visualization when we're looking at these categorical against categorical variables. All right, so it's coming up on 10:55. So before I take some questions, I actually just want to stop here and point you to some resources. So if you're looking to learn more, and what I want to point you to is this jump.com/teach section of our website. And so this is under, again, resources for users, or you can go directly to jump.com/teach. And this lists all of the resources available. And so the learning library would be the place I would point you to first if you're just learning JMP or if you want help on specific analyses. And the learning library, what it does is answer the question, how do I do X in JMP? So if you have a question about basic inference, let's say you have a question about doing a chi-square test for a two-way table, something we just looked at, you can view several different resources for this. So a one-page guide, which is a PDF you can download or print out, showing you step-by-step instructions with sample data for how to complete that analysis. You can also take a tutorial, which is a walkthrough of that analysis, or for many of these, you can click Watch Demo, which will bring up a YouTube video showing how this analysis is actually carried out. So I think this is a great way to get help, especially when you're just learning. Now, if you have a particular question about something in JMP, one nice thing to do, let me just bring some output up, is whenever you have output, you can go to the Tools menu and select the Help tool, which allows you to click anywhere in JMP. I'll click on Quantiles, and this will bring up the JMP help file for that particular output. And so this is a great way, especially if something is confusing or you're not sure what JMP is doing, just go to the Tools menu, select Help, and then click the section you would like more help on. Now that help file actually references, under this book section of the help menu, a particular section in one of the many different JMP books. So a lot of people, when they first get JMP, try to read through all of these. Now, it's not a bad thing. It's always good to learn more. But the JMP documentation library, so all of these books, I'll just show you, is 4,406 pages. So it's incredibly well documented, but I wouldn't suggest that would be the way to learn. I think it's always best to have a project or something you need to analyze and then work through learning those bits. And as you use JMP more, you'll probably become very proficient at it. It's a very intuitive piece of software. And so, of course, we're all here to help. And so I want to just give you my card and information, should there be anything you want to ask me about specifically. But at this point, I want to just stop, be quiet, and take some questions that you may have.